Welcome to the educational research section of www.happynumbers.org. Today's video is going to deal with the concept of the interquartile range. The interquartile range. By the way, my neighbor is doing some construction next door, so you may hear some sawing and hammering and things like that. We'll just have to deal with that. Some prior knowledge. To be able to get the most out of this video, it's recommended that you have a really good understanding of how you locate the median in a data set. And there is a video called Measures of Central Tendency which covers the median. So if you have not seen that, or if you're not very clear on how to locate the median, then you may want to take a look at that video first. Okay, the interquartile range. The interquartile range is a measure that we use when we're working with a distribution where the median is the most appropriate measure of central tendency. So let's take a look at it. Well, first of all, the range in a set of data. In a data set, we can compute the range, and the range would be the largest score minus the smallest score. And that would give us a very gross measurement of what the range of the data set is. But if we had extreme scores, outliers, then we might have a huge range which might not really be representative of what the data set is. So we use a concept called the interquartile range. And it measures the variability of a data set by looking at the middle 50% of the data set. At the middle 50%. So if there are extreme outliers, they won't even be considered because it looks at the middle 50%. Take a look at this diagram. Suppose this is our data set. Now there are no numbers here, but this is the smallest piece of data and this is the largest piece of data. This middle 50% of the data is called the interquartile range, and we're going to learn how to compute that, and I hope I'll be able to explain it so that it's not too crazy for you. All right, so let's take a look here. To find the interquartile range, we arrange the data in increasing order and find the median. So we would start with our lowest number data point here, and we put it in ascending order to the maximum piece of data, and then we find the median. So that's the median of our data set. So that's the first step. Then we find the median of the lower 50% of the data. Well, this is the lower 50% of our data because the median divides the data that half is below it and half is above it. So from here to here is the lower or the bottom 50% of the data, and we get the median of that point. So we take the midpoint between here and the minimum score, and that is called quartile 1 or Q1. And that is the median of the lower 50% of the data. Now we do the same thing, except we take the median of the upper 50% of the data. So this is the median, and we go to the maximum score, and we take the median of the upper 50% of the data, and that is called Q3 or quartile 3. So the middle 50% of our data falls between Q1, quartile 1, and Q3. And so that is referred to as the interquartile range. The data points between Q1 and Q3. Now you'll notice, well, you'll notice that the Q1, the median, and Q3 divide the data set so that there is 25% of the data in each of the areas. And that middle part, the middle 50%, is called the interquartile range. And to compute the interquartile range, we say Q3 minus Q1, and that gives us a measure of spread of the middle 50% of the data. So we'll take a look with some numbers now. Okay, this is our Best Actress Oscar winners, and it's a stem plot. It's a stem plot. So, to find the interquartile range, we arrange our scores from the lowest. This is what I did with the stem plot. This is 21 and 25 and 26 and 29. So if you have not seen the video on stem plots, you may want to look at that if you don't understand this. So this is the bottom 50% of our data right here. So Q1 is the median of the bottom half of the data. Since there are 16 observations, here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Since there are 16 observations, Q1 is the mean of the 8th and 9th observation. If you remember, you would take 16 and divide it by 2, and that would give you 8. And then 16 plus 1, and then add 1 to it. And it would be, so it would be, Q1 would be 31. That's 1, 2, 3, 4, 5, 6, 7, 8. So 31 is the 8th, and 33 is the 9th. And so if I added 31 and 33 and divided by 2, I get 32. So Q1, the mean of the median of the bottom half of our data set is 32, because it is the mean of the 8th and 9th scores, 31 and 33. So it's 32. Now, since there are 16 observations in the top half, then Q3 is the mean of the 8th and 9th observation in the top half, and the 8th and 9th observation in the top half would be 1, 2, 3, 4, 5, 6, 7, 8. So it would be 41 and 42. So the mean of 41 and 42, so Q3 is equal to 41 plus 42 divided by 2, which gives me 83 divided by 2, which gives me 41.5. So my interquartile range is Q3, which is 41.5, minus 32, which is 9, and that gives me 9.5, and that is the interquartile range. Let's look at this again. To get Q1, we have to take the median of the bottom 16 scores. Well, the median of the bottom 16 scores would be between the 8th and 9th score, which is 1, 2, 3, 4, 5, 6, 7, 8. So it would be 31 and 33. So if we add 31 and 33 and divide by 2, it's 64 divided by 2, and that gives me 32 as the median of the bottom half. And that's my Q1. So that's right here, 32. Now to get Q3, we have to take the mean of the 8th and 9th score in the top half of the data. This is the top half of the data right here. So it would be 1, 2, 3, 4, 5, 6, 7, 8. So that would be 41 and 42. So the mean of 41 and 42, when we add them together and divide by 2, we get 41.5. And that is Q3, which is right here. So we subtract Q1 from Q3, and we get 9.5, and that is our interquartile range. Okay, let's see here. Okay, now, we can use the interquartile range to detect possible outliers. And outliers are extreme observations in the data set. And here is the criterion for identifying outliers. If we take the interquartile range, whatever that is that we compute as the interquartile range, and we multiply it by 1.5, here's the interquartile. Any score that falls below that result or above that result is considered a possible or suspect outlier. Let's use an example here. This is our Best Actress Award winners again, our Oscar winners, and this is the data set right up here. And here is the histogram of that data set. Now, we know that Q1 in our data, because we've already computed it, is 32, and we know that Q3 is 41.5. And we know the interquartile range is Q3 minus Q1, which was 41.5 minus 32, and we had computed it on the previous screen, and 9.5 was our interquartile range. So now we're going to take Q1, and we're going to multiply the interquartile range times 1.5, and we're going to minus that answer from Q1. So Q1 is 32. If we multiply 1.5 times 9.5 and subtract that result, we get 17.75. 17.75. So any score that is 17.75 or below would be considered an outlier in the bottom half of the data set. But we don't have any scores at it. 21 is our lowest score. As you can see up here, 21 is the lowest score. So there are no outliers in the bottom part. Now, if we take Q3, which we knew was 41.5, and we multiply 1.5 times 9.5, and we add that product to 41.5, we get 55.75. Any score that is above 55.75 would be considered a possible outlier. And we have 3 scores in this distribution: 62, 74, and 80, which are above. So these are considered possible outliers. So again, let's review this concept. To identify possible outliers in a distribution when we're using the median and interquartile range, we take, in the bottom half of the distribution, we take Q1, and we multiply 1.5 times the interquartile range, and we subtract it from Q1 because Q1 is the bottom part, so we're subtracting it. And any number that falls below that result, in this case 17.75, would be considered an outlier. But there are no numbers down there in our distribution. Now, if we're going to look at the top half of the distribution, we take Q3, which we had computed for our best actresses as 41.5, and we multiply 1.5 times 9.5, 9.5 being the interquartile range. 1.5 is a constant, 9.5 is interquartile range. And we add that number to our Q3, 41.5. We get 55.75. Any numbers in our data that are above that are suspect outliers. Suspect outliers. Well, that's a lot. All right, let's move on here. Okay, your turn now. Using the following data set, determine the median, Q1, Q3, the interquartile range, and identify any possible outliers. Wow, that's an assignment. Well, if you're up for it, put the video on pause and see if you can work your way through that. And you can always go back and review what went on and see if you can work your way through that. And then turn it back on and we'll look at it. Well, if you were a trooper and made your way through it, let's see how you did. First of all, the median. There are 19 scores, so the median lies at the n plus 1. 19 plus 1 would be 20 divided by 2, which would be the 10th score. The 10th score, 1, 2, 3, 4, 5, 8, 9, 10, so the median is 34. Okay, now let's go for Q1. Q1 equals the median of the lower 50% of the scores. There are 9 scores, so Q1 lies at the n, 9 plus 1 divided by 2, 10 divided by 2, at the 5th score, and the 5th score would be 1, 2, 3, 4, 5. 5th score is 16. All right. Q3, that's the median of the top 50% of the scores, and there are 9 scores in the top. So Q3 lies at the 9 plus 1 divided by 2, 10 divided by 2. The 5th upper score, 1, 2, 3, 4, 5, so there's Q3. Our interquartile range is Q3 minus Q1, which would be 42 minus 16, so our interquartile range is 26. In our outliers, well, we have Q1 minus the product of 1.5 times the interquartile range, which would be Q1 is 16, and the product of the interquartile range, which is 26, and 1.5 is 39, so we wind up with a negative 23, and therefore there were no negative numbers in our data set, so there are no outliers there. But in Q3, we have Q3, which is 42, plus the product of 1.5 times the interquartile range, and the interquartile range is 26. The product of 1.5 and the interquartile range is 63. If we add that together, we get 105. So any scores in our data set that are above 105 are possible outliers, and we have two possible outliers here, 108 and 132. Well, if you were able to navigate through that, then you have a very, very good understanding of this. Good job. Let's take one other quick look here. Sometimes it's important to interpret outliers, like when do you keep an outlier in the data set and when don't you keep an outlier in the data set? Let's take a look at here. Here we have the magnitude of California earthquakes from August 28, 2000 to September 9th, 2000, and there were a total of 460 of them. This is the magnitude of earthquakes on the Richter scale. The higher the number, the stronger the earthquakes, and this was the frequency of them. Okay, well, we have one outlier, and it's only one earthquake, but it's way, way stronger than the others, way, way stronger than the others. Since this outlier, it may be very important to consider because a strong earthquake can cause a great deal of damage. Smaller earthquakes might not even be noticed. They may not be so significant. Suppose you're building a building, and you say, well, gee, there are a lot of earthquakes, but they're small. Oh, well, there's just one that was large. Well, that one that was large is very significant, so you would want to keep that in the data because you would want to build your building to the standards of at least that one, or if not greater. So sometimes it's important to keep an outlier. Sometimes it's important to keep an outlier. You need to look at the data and just what the data is about to determine that. Now here's a Philip Morris Tobacco Company stock returns from July 90 to May 1997. And here's the citation where it came from. And this is the monthly return on stocks. Well, we have an outlier down here. The stock was very low. Well, what we need to consider is that in the early 1990s, there was a lot of publicity and hearings going on about tobacco causing cancer and big health problems and things like that. And the public was very much against smoking. And therefore, the price of the stock went down a lot. And as we can see here, the price is fairly normally distributed. Well, this event is sort of a freak event that happened one time, and it's not likely to repeat again. So in this case, you would probably not use this outlier in the data set. Again, the point being, when you have a data set with outliers, it's good to try and understand the entire data set and what is going on as to whether you will include the outlier or exclude it. If it's an unusual circumstance that's not likely to repeat over and over again, then you probably want to drop that piece of data. However, like the earthquake, that one strong earthquake would be very, very important in that data set. Well, here's the summary. The range, which is a very gross measure of dispersion in a data set, is just the largest number minus the smallest number. The interquartile range is the range covered by the middle 50% of the data. The interquartile range is quartile 3 minus quartile 1. That's how we compute it. The interquartile range should be the measure of spread of a distribution only when the median is used as a measure of central tendency.
When the median is used as a measure of central tendency, then you want to use the interquartile range as a measure of spread. The interquartile range can be used to detect outliers using the interquartile range times 1.5 criterion. Well, thank you very much. This was a lengthy video. See you next time.